buenos, bienvenidos. I didn't understand anything of what he was saying, but anyway, so I can auto-introduce myself. I'm working at University of Roma Tre, and thanks Jesus for inviting us here. It's a pleasure to be here. We self-invited us because we like the environment. But anyway, it's a pleasure that you host us, at least. What I'm going to talk today is something related to the quality evaluation. So how do we measure the quality of experience, of quality of service, of new media? What you saw yesterday from my colleague is, because actually she's really a colleague, and you saw an introduction to quality. And now we are going to the tough part, that is, how do we measure the quality? So I don't know if you are familiar with the concept of quality metrics. Yes. Is there anybody that doesn't know anything? Perfect. So, where I come from, Roma is here. That's Roma. So I'm from Roma, and this is actually the third University of Roma. It was a portion of the University of La Sapienza. We are a young university, pretty young. We have been established in 1992. We are 37,000 more or less students, so it's pretty small university. And we have 13 departments where you can choose. There is almost everything but medicine. Personally, I belong to the Industrial Electronics and Mechanics Engineering department. That, of course, is one of the best. When I'm now, what is the main characteristics of Roma Tre? That we didn't build new buildings, but the idea was to recover ancient buildings. So, for example, this is the ship model basin in 1927. You know, when there is this long basin with water, and you can put your naval toy in order to check how the water is going. And then in 1950-60 it was abandoned because they built a new one. This was the status before the university, and now it has been completely renewed, and this is where we are now. So you are kindly invited to see this person. I belong to a nice group that is MUSE, Multimedia and Security Group. It's not only Roma Tre, but it's spread around the world, I would say. Padua. Now there is also some ancient Indian PhD student, and we are working on mobile communication, digital image processing, multimedia quality evaluation, security, and so on. You can find more information about projects in that nice website. So back to quality. We can hear very often about this word convergency. Convergency means that there are several things that are together, trying to fuse together in order to give an experience to the final users, a better experience to the final users. Well, this is convergence of media, channels, industry, regulation, and so on. These are ideas. Actually, in reality, it's not often working. You saw yesterday the example of the 3D, of the stereo systems. A lot of nice idea, but at the end, nothing works. And what we are trying to do now, from a research point of view, is to understand not only why it didn't work, but how the new technology should be used, what we should do in order to let this convergency work and give a nice experience to the final user. So concerning multimedia, the nice word now is interactive multimedia. Everybody is talking about interactive multimedia. That requires multimedia, that is not only video and images. Actually, multimedia means multimedia. So many media means to deliver information that can be tactile, that can be smell, that can be audio and visual information. Interactivity is something different from having what they are doing now, just looking in front of the PC. Interactivity means that I need to have the feeling of being there. Okay, that's interactivity. Like now, I can touch this one. I can feel the weight. Okay, it's not only one that we see in virtual reality. We can use the headset to touch an object, maybe even to rise up, but then we don't feel the weight of the object. So our sensation is different from the one that we really have. This is what I mean with the feeling of being there. Well, it requires personalization, it requires easy to use, it should be wherever, and the technologies behind this interactive multimedia are many. Nowadays, artificial intelligence is one of the most used words. From a device and content point of view, well, the idea is to bring objects into the personal world. Again, at the end, we have a person. And our personal world, as we saw yesterday, and I will show you later on maybe, is that we have something that is close to us, like personal, something that is in around one area, 1 meter of distance. Remember, local area network, personal network, body network. If you are from a network point of view, well, that's the goal, the idea. To have something that is close to us. And practically, we need a lot of things in order to return this sensation. We're now tackling with the quality. Quality, as everybody knows, so I go fast in these slides. There are so many things that can work against having the perfect quality. For example, acquisition artifacts. They have coding artifacts, transmission artifacts, processing artifacts, rendering artifacts. All the chain that is not only source coding, channel coding, transmission, and that's it. We have also the source generation, the rendering. All of them can create artifacts. And the goal, the problem is how to measure this quality. This is what Federica was talking yesterday, this elephant. If I have blind people, well, according to the different aspects that they are looking for, they will give us different answer. It means that the application is something fundamental. The specificity of the scenario that I'm taking into account gives us a different aspect of quality. So not just like SNR, signal to noise ratio. It's something different, it's something more complex. And we can measure in the quality using two different systems. One is objective metric and the other is subjective metric. The objective metric means that we have something that is measurable, so that as engineers we like a lot, something that we can measure. It gives us a number, and based on the number we can rank. This is our goal. We always started like that. If you think again to the SNR, it means that we have a signal that we know at the receiver side. We compare with the signal that we received at the receiver side, and then we measure the quality of the transmission. However, I'd like to remind you that this means that at the receiver side, we already know which is the signal. Okay? Only in this case we can measure the SNR. That is, from a quality point of view, means that we already know the gigabyte of the data that we have shared. That's not always possible. Anyway, this is the objective system. On the other side, there is the subjective, the human-based. And the human-based is based on something that is personal, specific of each person. But if we average over a large number of people, then maybe we can derive some numbers that more or less, in the average, gives us a judgment about the quality of an object. How do we measure from a subjective? So let's start with subjective, with a mean opinion score. Mean opinion score, that's the definition, is the level of likely, okay, is not certain, is likely level of satisfaction of a service appreciated by an average user. Here we have some problem because it's likely, we have an average, and somehow we have the appreciation. Nice word from a philosophical point of view, but from an engineering point of view, that's quite different. We have subjective evaluation. In order to obtain such a thing, we have to have a subjective evaluation methodology. It's pretty complex. We have to have somehow a scale. We need to teach to the user, well, think what is very annoying. Think to something that is so beautiful that you would love it. To this, you give 5. To the other one, you give 0. So you need somehow to let the people match what is their judgment with some number. This is something that should be done. Okay? Now it's not working to me anymore. It's probably is the battery that is low level battery. So the subjective score is not only it's not so easy because it's the results of the test environment, the test material, the test methodology, and after, at the end, the analysis of the data. This thing, well, I will walk further. Next, please. Environment. Environment should be as isolated as possible. Because if I'm measuring the quality and there is a classroom outside, people making noise, I can be distracted. So there is something that attracting my attention. So that means that the lighting should be the same. The acoustic conditions should be perfect, no external noise. The viewing distance, the hearing position. Why? Because I want that the subject is concentrated to what is looking at. Is it this real? The answer is no. Because when I'm looking television at home, I have other noises. I have other people in the house. I can hear the traffic jam downstairs. However, in order to have some judgment, the idea is to have this kind of condition. Then the material. I need to show something that is covering the whole scale from no artifacts to very worse artifacts. The methodology, how to enroll the subject, which are the instructions that should be given, which are the questions, how is the training. So even doing a subjective experiment, I think that some of you did some subjective experiments. We have the training, the presentation, and then the grading scale. Next, please. Studied a lot, several recommendations, several working group, IEEE, BCAG, and so on. They are giving some protocols in order to what means standard deviation, standard viewing conditions, subject selection criteria, and so on. So there is something that is standardized. If you do your tests in this way, then people is trusting your result. Because if they conduct the same experiment in another country, maybe there will be some difference. However, the results will be somehow the same. And for a testing room, the viewing distance is important. The color, the background, the display, which is the size of display, and so on. Subject selection criteria. You cannot take everybody, because if you're looking something about the color and the person is colorblind, then is judgment. So some selection should be done. Can everybody see all the numbers inside? No. When? I can't. Okay, what's written here? People, right. Is everybody able to see this number here? Well, this is something that sometimes you ask, no, there is no number there. Hold on. Usually, I'm joking, there is a number. Because what is the difficulty that you know if you are colorblind, if the particular specific frequency is the green or red, so it's something that is really, you know, because you don't see, then it's the problem. But very often you don't know if you are colorblind to some particular frequency that do not affect your normal life, however, they affect our quality judgment. So this is something that you probably know. How to present the results? Yesterday you heard about it. Single stimulus, I means that I only show you no reference, okay? Only the received one, the image or the video or the something that, this is the results of everything. Whatever is before is a black box. I have this, please judge. And then is this 5 scale. Or the stimulus comparison, in which you show two different images. Maybe the first one is the original one, and the second one is the impaired one. And in this case, it's pretty clear, I hope, for everybody that this is not the original one. Sometimes you shuffle them. You don't say which is the original, in order to let the people not concentrate only on that one. And then again, you have the stimulus comparison. Okay, just to go faster, in somehow the thing is pretty easy. Which one do you prefer, left or right? Right. This stuff is not working again. Which one do you prefer? Who prefers the left one? Who prefers the right one? Someone. Even in this case, it's fine, but somehow it's difficult. After you have collected all the data, then you do some data analysis. What you are collecting is the opinion score. You say some confidence interval, so you try to derive these numbers. That gives us some result. Which is the result? That the subjective quality assessment for sure is the best way to give us a rank. However, it's time consuming, especially if you're working in a company. It's costly. They require a careful setup. And if you're doing online or real quality monitor, you cannot very often do this subjective quality assessment. Is it working? Now you could try. Ta-da! Perfect. Let's go to the objective, other word, the objective quality metrics. There are the classical, root mean square error, sigma to noise. All these metrics are measuring pixel-wise method. I tried this morning when the connection was still working on Google. How many image quality metrics there are? Try to guess. More than 300,000 results. So it's something, a subject that's been very well studied from image. For image, we know exactly, even if somehow there is every once in a while there is a new metric that is improving of 0.01 the accuracy with respect to the MOS. The objective metrics, they do not consider the influence of the content, the viewing condition, the application. They are not reliable predictors, however, they are used. Okay, the most two used are PSNR, that we know is worst, and SSIM. Okay, and MSSIM. So, Well, I will go fast. Full reference, reduced reference, no reference according to the availability of the original signal and so on. Everybody, I think, agrees with me that PSNR is, in this case, is given the right ranking, okay? Because it's lower. Lower PSNR means worse image. While in this case, I think that everybody likes more, I don't know what. Which one do you like more? This one, the original one. However, for the PSNR, that's more or less they are the same. So that's the reason why the objective metric doesn't work too well. Summarizing, objective work do not always correlate well with quality and require a reference that is not often available. Subjective fidelity criteria is time consuming, and that's it. So, take home. You are able to rank the quality. Is it true? No, you as a subject are able, if I show you an image, you told me I prefer this one with this other one, okay? Then, why? Because you are used to the image. We are used to video. And you are sitting down in front of your computer. Okay, or your monitor, or your smartphone. This is something that you know. Where are you now? Here, in your comfort zone. The idea is, with immersive multimedia, to move from that circle, to move away. We are going in a different world, that is the immersive system, where the magic happens. In fact, it's much, much nicer. However, jumping from here to here requires a lot of knowledge, a lot of effort. And what I'll show you in the remaining part of this seminar is the attempt to go in that direction. Even the user, for the users, is a quantum leap, is a big jump, okay? But there is, so it's much nicer. Technology is still, you will see that technology is still far to be what we need. The metrics, our knowledge is still far. However, we should go in that direction. And this is one example, is the a system for immersivity. Holographica, you know holographica. We are in front of a screen. What is the difference from this and a video? That the image, the data are the same. It's the user that is moving. When you are moving your head up and down, you see always the same scene. No, it's changing. Because you are changing your point of view. With this system, that is a pretty expensive monitor, let's call monitor, but it's so huge, then you can show the reality in a different way, allowing to the people to change the point of view, like you do in the real world. And one way to obtain this data is through, for example, the light field. Light field, how many of you knows? So I can go faster, everybody, perfect. Light field is the idea in one image. What you do is to record the ray RGB that are hitting one point, and that's it, you have a static image. In light field, what you are recording is the complete light field that is hitting one point in your sensor. And of course, is called the theory is the planoptic function. And we had several attempts in order to record this light field. One is this one, to use a lenslet in front a micro lens array in front of a photon sensor. We obtain this image here, and by the combination, by the post-processing of this data, you are able to build an attempt of the light field. everything becomes more complex. Single image, okay, 2D image, processing, coding, distribution, decoding, rendering. In this case, we have this data, because it's light field. So we have pre-processing, coding, distribution, decoding, and then post-processing. What is the freedom? That we can have a different kind of rendering. So the people can browse this information in many different ways. Let's start with one of these. We were working with Jesus on this one. Like, how do you render such an information to the user? It's not a 2D image. But what do we have usually at home or in pocket? We have a 2D display. So, virtual reality, we need to have an headset. Light field display, the one that I showed at the beginning, very, very expensive, or 2D display. So the first attempt in order to render this data was to use, let's see how the people can see the information by using a 2D display. There are several techniques, as a grid of viewpoint images, as a lenslet image, this one that is not pretty nice, or in a different format. This is, you see, extended depth of field, pseudo video, refocus video. As you can see, you can choose after you have shot which point to focus on, and then you can select particular specific points. We did some experiment in order to evaluate the quality of light field when shown using a 2D display. The idea was to, first of all, to select some sources, to do a subjective experiment using different coding and showing the results with different systems to understand which was the preferred one by the subjects. From the test performed, it seems that there is a lot of confusion. Okay? And this confusion is due to the fact that we are not used to. So the people was trying to match his knowledge with something new. Pseudo video, more or less the blue, more or less was the one preferred. Okay, pseudo video means that I've taken each image and I've collected one after the other one, and then I created a video. This is a pseudo video. Okay, and you can see there is some motion, like you move the head. How big can be this motion? Well, it depends on how many lenslets do you have. Nowadays it's very small, so at maximum you can do a very, very few motion. However, people was preferred the pseudo video. The answer is probably because they were used to video, rather than seeing something that changed focus. These images one after the other one. There are several techniques. For example, this one. You put one after the other one, like in a spiral. Then you can select them in a diagonal. Then you do like this, like in lexicographic order. First line, second line, third line, and so on. So we did another experiment with different collecting techniques. Again, following all the rules, and the results, even not so perfect. I would expect something nicer, but however, there is an indication that this pseudo video taken in this way, that is here, is the one that is most appreciated by the user. What we can, if we have a 2D display, the best way to present a light field to the user is to create a video selecting the images from the micro images following this direction. Okay? Following with this scheme. This is one result that we have up to now. Which is the future of light field? Well, still research is ongoing for compression, because you can see that the amount of images that we have from one shot is huge. So from compression there are standardization efforts going on, there are compression. However, what is missing is the consumer electronics. The light field camera, they do not exist anymore. So we are talking on something that it seems at the beginning to be a huge future, to have a huge future. However, nowadays the light field camera is over, because it was expensive, because the people didn't like too much the result, because it was difficult to exploit the information. Is it died? No. Why? Because the concept of having several cameras and maybe able to select the point of view is the core of the multi-view system. The future of television will be this one, in which I can select from which point to look at. Okay? So it means that I have to have several cameras, like an array camera, and select every time I want to move from this camera to this camera to change my point of view. Think to be in a soccer game and to be able to move around the player. That's the future of television. So the study is still good. Let's change. Immersive system. Virtual reality. You saw it yesterday. 6 degrees of freedom. What is the scenario that have been devised are gaming, training, planning, remote scenes, and so on. The first thing that we did, is it true? Can be useful or not? What she is doing according to you? By the way, this is our building. Can you guess what she is doing? Yeah. She's looking at the virtual museum. It's one application that can help people that is in a different location to enjoy something that is remotely. In this case, so is it working? Yes. So for remote exploitation of arts, it can work. Let's see from the other topic, that was training. Well, the training, we had a project that was related to the use of immersive system for security, for safety, in critical situation. And so what we did, we organized a training for firefighters to be operated after an earthquake. The firefighter, usually what they do is to have a paper instruction, and they know exactly what to do. Because when you are in operating scenario, you have to have real, perfect knowledge, with no doubt, of which are the procedures in order to get to the point. So we had the two types of training, one based on instruction, and in the other one we have rebuilt in a virtual scenario what was the basement where we had the real experiment. Okay, so and the people could have training using the VR to the operation that they should have done. Okay, then we did the real experiment, and we were then comparing the results, the usability, trying to understand which is the effectiveness, the efficiency, the satisfaction of the users in both cases. people using paper and people using virtual reality. The results were, of course, nice, but what I want to point out is that even a real firefighters was using the VR system to test. He did everything, and at the end, when he was sent to the basement, they didn't know, of course, what he had to do. After the training with VR, he was taking more time than the other people. I was thinking, why? So you are an expert, you already know what you have to do in particular in specific case, but then you are taking more time. That was one of the parameters that we were measuring. The answer of the firefighter was, yes, but it was so nice that I was enjoying the new system, the new world, rather than looking at what I was supposed to do. This is an alarm. It means that if you want to have for training, we need to somehow let the people be adjusted, accustomed to the specific system. Well, from the people seminar, you saw that the attention, because then we need to, at the end, we want to measure the quality, and the attention is something that can relate us, because if something is damaged, but the people is not looking at that area, my quality judgment will be better, okay, will be higher. Can we use what we have up to now for 2D images in order to detect what is important for the human being? Like, for example, face are relevant. Okay, there are several face detection systems, and let's see if you can use them. So we have used two of the best performing face detection systems that probably you know, Viola Jones. You know Viola Jones, right? Yes. And TinyFace, that is based on a convolutional neural network. One is perfect for 2D images. It's a long story behind it. And the other one is used especially for fisheye images, so it's worked very well. If you know, or if you remember how is the 360 images, is not a perfect image because it's a sphere that is projected on a 2D region, so it has some distortion. We applied Viola Jones and this algorithm to the three types of magic. Then we did the subjective experiment. We have selected different data sets in order to be fair with the two systems. Well, the results are that TinyFaces on 360 image is better than Viola Jones. And this was almost expected. So it's okay. Then we went more in detail because people were saying, yes, but I was not looking at all the faces. So the question is, in a 360 world, when I can move around, are all the faces so important to me? Because if I want to measure, you know that if you have an image quality assessment system that it takes into account also the faces, if an artifact is affecting the face, I usually give a lower rank because faces attract human beings. So then we did another experiment. We asked to the people to count how many faces they saw in the image, in the 360 image. And then we compared this value with the one evaluated with the automatic TinyFace detector. Well, this is the result according to the number of faces for different images. If there is no faces, people, they say no faces. As soon as we go up, people start, is the blue one, counting a lower number of faces. What does it mean? First, not all the faces that an automatic system is able to detect are important for a person. So this is something. Second, that why they didn't see, we asked, why you didn't see all the faces? Because somehow, these are the cases, worst cases, for example this one, they were confusing. Or remember that you have to turn your head. Because you are in an environment where, like you, if I'm sitting here, where there was a centric position, I'm here and I have to count, I 1, 2, 3, 4, then I have to move myself, okay? And in a fixed time, I don't have time to look at all of them. So there are two results. First, not all the faces are important. Second, and this is for research topic, we need a face detector in 360 world, because the 2D, they do not work perfectly. And this is something that is later on to derive a quality metric, we need to somehow assess the significance. Again, something that is related to the human being. What is related to human behavior is this one, but I will go fast. The proximity. So what is close to me, and this is useful especially for the interaction among people. Again, this is something that must be considered in the immersivity world, but we are still at the beginning. The last thing that I want to show you is something that we did recently with some students. It was in a school. Okay, this is a church in Roma. They have acquired the church, and then with laser scanner, and then they have created this video. As you can see, when you point on a particular area, there is this extra information. That is what is virtual reality for education. Okay, you point, you see, and then you have extra information. And this can be also personalized according to your level, knowledge or level. You can have, okay, this is a painting, or this is a painting made with some particular colors and so on. You saw the video? It's over. According to you, is this video good for a virtual reality environment? Or are the techniques that we have used, the students have used, are they enough for resulting in a high quality experience of the people, of a user looking at? The jerkiness of the video is only due to the computer. Let's So, come on.
Maybe the lighting is not realistic enough for an immersive experience.
It's
difficult to judge who are comparing because you are not close enough to see the quality that you are going to see where the image.
Okay, lighting, then 360, then what else? I usually throw then any other idea? Any other comment? Think that you need to do something that the future generation will use it. Too much or too small?
Too much.
Well, we can zoom.
The figures are not that expensive.
Figure of the okay, this is, but they are steady. They are still there from centuries. The church is nice. It's San Saba in Roma, if you want to go. No. Everything is too perfect. Well, I would put together these 2 points, because one is related to the light that it doesn't seem natural, and the other one is too perfect. Again, is naturalness, I don't know if it doesn't exist, this word, but feeling. Quality of experience means that we have to do something that the people feel real. Okay, concerning the light. Light, unfortunately, is important, because in order to record not only the points, but even the RGB information, we had to have a strong illumination, because that was a dark scene, and the light was like a spot. It means that if we want to do something more, we have to have diffuse light, not spot, that should be somehow matching the illumination required by the camera, the RGB camera, in order to have enough information. This is light, but it's true. Too perfect, no depth information, yes. It means that we should do what? Post-processing, in the meaning that if the region is far from the point of view, it should be somehow blurred. And once I move, the depth should change according to my motion. What should I do? I should keep in mind that I need, from the starting point, to measure the motion of the person, the direction of the head in the headset. So all things that I need to do in real time in order to adapt the scene before showing it to the user.
Also the eye tracking.
I need to use the eye tracking. So the headset, like the HTC Vive Pro, is not enough. I need to have the HTC Vive Pro Eye. Okay? How much does it cost, an HTC Vive Pro Eye? It's still hard, but from a museum, maybe not. Okay, from a church that wants to show his, maybe it's not too high. The Oculus is 300, maybe just less. Technology is improving. Technology is improving a lot. Text. The idea of text is to, like in the museum, I'm coming to him and I'm clicking, and somehow it appears some information about his career. If I'm interested in this paper, maybe I have a personalized access. So I'm an expert in something, I want to know about this paper in water conditioning. Then it appears some information, the papers around water conditioning. So the amount of text must be related to the interest of the person. Do you see that we are not taking into account only about the technical, the acquisition, the rendering, but also on the features of the final user, what is interested on. The quality of experience is this one. And this example for me is very good because it's showing you what is the quality of experience. We are not even close to measuring the quality of experience. We are now dealing with some fatigue of how the several steps should work in order to give a quality of experience. Okay. What is the worst thing according to me? That I need to go back. If I have an head-up display and I put it I will be at half a meter from the floor. That was the height of the camera. And if I look down, I will see it. But if I'm doing up and down, I will not see the real scene. So it's like viewing everything from one point. And even the motion is rotating around the point. So in order to have a real rendering, I should have taken the camera, different position. Again, remember the beginning multi-view? Multi-view is taking from this position, this position, this position, this height, this height, this height, and then eventually interpolating them in order to give the opportunity to the user, if I'm moving, I don't see something that is rotating, but I see something that is going, okay, in this direction. If I go back and up, how many gigabytes do I need? Coding, transmission, 5G, well, let's see. If we want to integrate now even the next feeling, that is the tactile, the smell, well, things are getting worse and worse, okay? But as you can see, it's pretty interesting, at least for us. Critical issues, a lot. Latency, in order to have a nice experience, everything should be, so we should have a real-time system, adaptive stream management, error resilient, concealing, missing points, high quality rendering, not heavy headsets, so there are so many problems. Well, all what I show was, I should say thanks to my colleague, of course, to the students at Mose, and we should say thanks to the volunteers. There were students that were so kind in the years to give us their results. And I don't know how many, but we say thanks to the almost volunteers. And this is the final message. Keep working. Thanks a lot, and that's it.